In this section, we will study the 8051 pin diagram, and we will also see the port structure of 8051, and we will see how to configure 8051 port as an input port or an output port. Also, we will understand some programs which can read the ports and programs to write the port. These are assembly level programs, and we will see how to access the port pins and read the pins and write the pins. So these are the topics which we will be seeing in this section. So as a introduction, what we will see, the basic structure of 8051 pins we will see here. Let us see the 8051 pin structure to explain the 8051 port functionalities. We know that 8051 is a 40 pin IC. So if you look at this 40 pins, we have 4 ports here. So there are 4 ports. The 4 ports are P0, P1, P2 and P3. Each ports are a 8-bit port. So this is an 8-bit port, each port. So then you say there are 8-bit port. Totally there are 32 pins. So we can see there are 32 pins which is there in this 8051 IC. So all these 32 pins can be used to access the external world, to connect the peripherals and all other things. Now, as we see in the diagram, we have also the power supply, which is 5 volt. Generally, we will be giving for the powering of the 8051. And other than this port, yes, we have the crystal connections to connect the external clock, and we have the ground here, and there is a reset pin here, and also we have some control signals to connect the external memory. So these are the pins which is available in 8051. So however, in this section our concentration is mainly on the port structure. So to summarize, 8051 has got a 4 8-bit port. So 4 8-bit ports which gives rise to 32 input output pins. So these are the pins which is used to connect externally peripherals. Pins can be individually used pin by pin, or we can use even 8 pins together, that is ports also can be connected as a port itself, I mean together with all the 8 pins. So to coming to the explanation about all these ports, we know that there are 4 8-bit input-output ports, as we just now mentioned. Each uses around 8 pins. All the ports upon reset are configured as an input, and this is to be ready to be used as an input port. So this is one important thing we should understand. When you switch on the microcontroller, that is when you reset the microcontroller or switch on the microcontroller, all these ports will be configured as an input port. This is a very important point. So input port in the sense like, see, by default it can receive the signal from an external device. So all the ports are configured in such a way that it can receive the signal. That is the default configuration of any port pins. Okay? So when it has to be received means there is some condition that we need to write. When you see the port, when you see a port, there are 2 aspects for the port. One is the latch associated with the ports. This is inside the microcontroller. So if I take the microcontroller, and this is the pin of the microcontroller, there is a microcontroller and pin of the microcontroller. We have the pin side of the port and the latch side of the port. So there are 2 things. Okay, so now in order to configure the port as an output port, you must write to the port 0. So that's what is written here. When first 0 is written in the port, it becomes an output. So if you wanted to uh, uh, write something to the port, this port must be loaded with 0 first. So when we are loading 0, basically we are making this latch value. This is the latch. This latch value was 0. Um, latch and pin. Okay. Now, if you need to configure the port as an input port, then you must remember this. We need to write a 1 to the latch or the port. Okay. So these are the two aspects you must always remember. So you must remember that there are two aspects here. You can configure a port as an input port or as an output port. And if you wanted to configure the port as an input port, you must write 1 to the port. Write 1 to the port first. That's what. So you must write 1. This is what we need to do to configure the port as an input. So if you wanted to configure the port as an output port, you must write 0 to the port. Okay, so any ports can be configured as an input port or an output port. Measures to be taken to configure it as an input port or as an output port. Okay. When it comes to 4 ports, all the 4 ports are input output ports. However, some of the ports have a different circuit structure. So when you take port 0, the port 0, you must remember that this has to be externally connected to a 10 kilo ohm pull-up resistor. So always to make this port to function properly, by default we need to do a connection as shown in the figure. So all the port pins you can see here, this is connected to a VCC through a 10 kilo ohm resistor. Like port 0.0 is connected, 0.1 is connected. So all the ports are connected to VCC through a pull-up resistor. This pull-up resistor, generally they suggest to use a 10 kilo ohm resistor here. So this is by default we need to connect it to make this port to function properly. Why it is to be why it is to be pulled up is because of the circuit structure. So this 8051 port 0 is having an open drain structure. Open drain structure, because of that we will be requiring this to be connected to a pull-up resistor to function it properly. So this is the case of port 0. So when it comes to port 0, it will act as a simple input-output port. So we are now seeing here one program. The program here says is the following code will continuously send port 0 the alternate values of 55 and AA. So it's a very simple program. In this program, we are sending 55 and AA. So we are sending 55 and AA to the port 0, and between each sending we will be calling a delay also. So you can see here how this program works is when you how this program works. First we will move 55 to the accumulator, so A will be 55, and then we will take this 55 to the port in the next line. So here P0 will become 55, and we will call a delay. So it will call a delay, so we will be waiting, and how much delay we are calling depends on what is the delay program which we will be using. So how much delay we are calling depends on the delay subroutine. So wait, so we will be having something called the delay subroutine. So this delay subroutine will take care of the delay. So this can be, delay can be any value. So depending on the delay subroutine, we will know how much is the delay between sending 55H to the port and sending AA to the port. So to send AA to the port, what we have to do is we will move AA to the accumulator first and then send accumulator to the port. So here at this point, P0 will become AA, hexadecimal AA. And if you see, again we will be calling a delay and we will jump back to the main program. So this program, what it does is, in this P0 it will become 55, then there will be a delay, and after the delay P0 will become AA, then again there will be a delay, and again P0 will become 55, there will be a delay, P0 will become AA, there will be a delay, so it will be keep on doing. So basically if you are connecting some LED or something to this P0, this LED will alternatively glow. That means 55 is 1010, sorry, 55 is 01010101. This is 5 and this is 5, and AA is 10101010. So if you are connecting LED to this port, alternate LEDs will glow here. That means wherever 0 is there, LED will not glow if you are using a common cathode LED, and wherever it is 1, LED will glow, so you will be seeing the LED glow. Suppose this red colored thing is glowing, so it will look like this. If the first 4 LEDs will look like this, and in this case it will look like this if we are connecting to the LED. So after some delay it will look like this. So it will be basically like LED will be blinking continuously for a predefined delay. Okay, so this is the first program, and so this is the first program which deals with the port 0. This program we have studied that how to send out a value to the port 0. So remember one simple thing. Earlier I have mentioned that to configure a port as an output port, we need to write 00 to the port first. I mean, we need to write the hexadecimal 0 to the port first. But in this port 0, if the port is pulled up to the VCC with the 10K register, we need not initialize this port 0, we need not write this 00 to the port 0 in the beginning. So in order to make it work as output port. Okay, so there is an exception for port 0. Remember, if port 0 is pulled up, if P0 is pulled up, then by default it will act as, so default it will act as an output port. So now if we need to configure this port as an input port, then definitely we need to write one to each pins, okay, or FF to the entire port. So this is one of the important thing you must realize. This is a speciality of the port 0 only. That is, default value is output when it is pulled up already. So this is a speciality of the port 0 only. With this understanding, let us now see how to read this port as an input port. The port 0 as an input port we will see here. So now look at this program. In this program, we need to make this port as an input port. Okay, that's the first thing. And how to do that we will see. Port 0 is configured as an input port by writing 1 to it, and then data is received from that port and send it to P1. That is what we are doing here. Okay, so what we do here is we will first write FF to the port 0. Why we are writing FF to port 0? To configure this port as an input port. So this entire code, these two lines together, is used for configuring this port 0 as an input port. So that means when you write FF to the port 0, what this is doing is moving FF to A and moving A to P0. That means as if we are moving FF to P0. We don't have an instruction called move P0 comma hash FF. That's a wrong instruction. So move P0 comma hash 0 FFH is invalid. Okay, so that is why we will move FF to A first, then A to P0. So this is only the valid way of doing it. So with this understanding, so you must remember that once we configure this port 0 as an input port, then we will, whatever comes in the port, so if you look at this line, we are moving the content of P0 to the accumulator. So we don't know what is the content of P0 right now. You may expect that the content of P0 is 0 FF because we have already moved FF to P0, but that's not true. Since we are moved FF to P0, and remember this P0 pin will be connected to some external devices. Okay, for example, if I take this microcontroller, okay, for example, in my microcontroller, if I have one pin which is of port 0 P0.1, okay, so inside the microcontroller I have sent FF, so I made it as P0.1 equals 1, so we configured it as an input port. But since this port is connected to some external device, let us take an example. This external device is uh, a switch or something. Okay, so when I say this switch, what I will do is I will just make some switch connection here. So VCC, one simple connection I made it here. So what happens is, even though we write P0.1 is equal to 1, or if you write move a comma hash 0 FF, and when we write move P0 comma A, that means P0.1 is also 1. That is what this two instruction does. However, when you read, when you next write move A comma P0, A comma P0, you don't expect we will be getting A as a 0 FF. We will not be getting A as 0 FF because this will be reading the port pins. So there are so many pins like this: 0.0, 0.1, 0.2, like this. Entire port will be available. In this, each pin is connected to some external device, and the status, suppose if this switch is connected to this P0.1, so the status of the switch, if it is like not pressed, then what happens is this value at this pin will become 0. So you will be getting a 0 here, and when you read the corresponding pin position, suppose if the remaining all are high, and the corresponding pin position you will be getting 0. So that means 1 1 1 1 1 1 0 1. This 0 corresponds to the P0.1, so that you must be remembering. So this 0 corresponds to the P0.1. So that is what, even if you are writing, that is what, even if you are writing FF to the P0, you will not be getting the same FF back here. The what you will be getting here will be the resultant of what is connected to the P naught. So if P naught is getting some high or low in the pins, those things will be reflected here and those values will be moved to the accumulator. And the next few lines we are moving that value to another port, and we will be keep on doing this. So remember, this is just a small portion of the program to explain you how to configure the P0 as an input port. And one of the alternate functionality of this port, you must be knowing that it is also used as the address or data lines when the external memory is connected. So that is the dual function of this port. So it is not only a simple input output port, it is also used for accessing the external memory, because we have only 40 pins for 8051 and we have a lot of functionalities which is to be done using 8051. So we have a lot of functionalities to be done with 8051. So most of the 8051 pins are having multiple functionalities. So one of the secondary function of this port 0 is to connect to the external memory, and the address bus of the external memory as well as the data bus of the external memory. The lower byte AD0 to AD7 is connected to P0, and this is a multiplexed channel. So we will be using the address latch enabled signal to demultiplex this address and data from the P0 in order to make it address alone or data alone. And when connecting to an 8051 to an external memory, port 0 provides both address and data. That's what we have seen. Now, we have seen in port 0 how we were configuring this port 0 as an input port, or how this is by default coming. It is acting as an output port when there is a pull-up resistor already connected to that. So now we will move to the port 1. So P1 is also used as an input port as well as an output port. However, there is a difference between P1 and P0. So the difference is that P1 does not require an external pull-up resistor. So that is the difference. Okay, why it does not require an external pull-up resistor? Because it already has a pull-up resistor internally available. So that's the reason it does not require an external pull-up resistor. And the default case is that is on reset. On reset, all the ports are configured as an input port. So all ports are input ports. That is the default case. And if you need to write something to the port, we need to write 0 to the port first. If you need to read something from the port, we need to write FF to the port. So let us take one example. I am going to make this port 1 as an input port in this program. So to make this port 1 as an input port, the entire port 1 must be we need to write 1, or all the pins, 8 pins must be written as 1. That means we need to write P1 as FF. The value should be written on this P1. So this is what we are doing in this program. So what we will be doing is here the port 1 is configured as an input port by using these two instructions. Here we will be using this port 1 as an input port by by writing FF to the port 1 using these two instructions. And once it is configured as an input port, then what we will be doing is we will be waiting for some values appearing in this port 1, and if anything appears in port 1, that will be moved to port A continuously, and that whatever the value what we are getting is, then we are moving to a register R7. So what happens here is A will be containing some value. So let me take an example. Assuming that we will be having a port which is connected like this, So we have our 805 on this side, and your external device, external pins, which is appearing at this side. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So let me say that this is P1.0, P1.1, P1.2, 1.3, 1.4, like this up to P1.7. Okay, and let me assume that let us assume that we are reading some data from this port. Okay, so reading the data from the port is being done by this instruction. So you must look here. We have this so you must understand we have this instruction. uh, we have initialized it to read or an input port. Then we are taking the data from port 1 to A in this line. Okay, so when I am taking the data, assume that the data available in this port 1 is 0 1 1 0 1 0 1 1. It may be like 0 means it is a ground here and 1 means it is a VCC. So the devices are configured in such a way that externally maybe it could be a switch or it could be a sensor or anything. It is giving rise to this data to this port. So that data, so what is this data? P1.0 to P1.7 means it is 1101 1101 and 0110 0110. So 1101, this is what is 1101? So we have 1101. Let us see what is 1101. We know that 1010 is A, 1011 is B, 1100 is C, 1101 is D, and 1110 is E, and 1111 is F. So 1101 is D. So this will be D, and this is 6. So that means the moment you read the content of this port to the accumulator, this accumulator will become D6. So remember, even though you feel like you have sent this FF to this port, but when you are reading, you are getting D6, not FF. Why? Because you are reading the pins of the port. Okay, so when you read the pins of the port, whatever is the voltages appearing on the pin only will be appearing on the ports also. And naturally, next what we are doing is we are moving that D6 value to the R7 register, and then we will wait for some time, and again we will read it. At this point we are reading it again. So that means maybe after some time, if this value changes, suppose after some 500 millisecond, okay, after some 500 millisecond, I am checking this pin. Maybe the values of this pin is changing. Maybe the sensor outputs are changing, or the key positions I have changed. So because of that, suppose if I get it as 0 1 0 1 0 0 1 0, something like this, if I am getting it, then naturally you must remember that the new data you will be getting after a 500 millisecond delay is this data, and that data is 0 1 0 0 1 0 1 0. So 0 1 0 0 is 4, and 1 0 1 0 is yes. So after some time, after that delay, if you see at this point, so remember at this point you were getting A as D6. However, at this point you will be getting A as 4A in this particular example. We will go to the port 2 as well as port 3. So remember, whether it is port 2 or port 3, both this can be used just like port 0 and port 1. It can be used as an input or an output port. And like P1, even see P2 or P3 does not require external pull-up resistors, and so the pull-up resistor is only required for port 0. External pull-up resistor is only required for port 0. That is to be clearly understood. Okay, for remaining all the ports, there is no need of external pull-up resistor. And this ports also, by upon default, it will act as an input port. And to write something to the port, we need to write 0 to the port first. To read something from the port, we need to write FF to the port before reading. So this has to be taken care for port 2 as well as port 3. So we have seen all the ports. Port 3 is having some additional functionalities other than this simple input output port. So this additional functionality is mentioned here. So if you can see here, there are this will also act as a simple input output port. Other than that, P3.0 and P3.1 is used for serial communication, and P3.2 and 3.3 is used as an external interrupt, and 3.4 and 4.5 are used for timers, and 3.6 is and 7 is used to connect to the external memories to read and write the content of the external memory. So these are the second function of this port pins P3.